Hi everyone. Today we are going to talk about system design in machine learning. I have called two experts to discuss this, Valerii and Arseny. They have recently published a book on this topic. Valerii and Arseny are well-known experts in machine learning. Valerii is Kaggle competition grandmaster, Arseny is Kaggle competition master. Both have worked in large number of successful companies. For example, Valerii works now at BP as senior principal for data and analytics, and Arseny helps startups with ML development strategy. There will be many references during this video to the guy's book. If you are interested, the link on this book will be in description, but we will talk generally about system design document and how to build working machine learning system. Let's go. Hi guys.
Hey,
Okay, we have a lot of questions today. Let's start. What experience do you expect from readers of your book?
I don't know. You see, it's hard if you don't pick who is the first, who is the second to answer. So, but as long as I've started this, I will continue. So I expect no experience until we define what we expect as an output after reading the book, right? So the book itself doesn't demand you to be an expert in a specific field. You can read it. It is written in language. It is easy to understand. Obviously, you won't understand everything until you know specific topics. But if you have some interest in computer science or some experience, which is better, or some experience in machine learning, which is even better, you might find this book useful. So we structured this book as a kind of manual you can take and read whenever you need something regarding specific topics discussed in the book.
Arseny, do you have something to add?
well, that's a pretty good summary. I would say that some topics can require slightly deeper experience. And in these chapters, we try to highlight that, well, to fully understand this material, you may want to familiarize or refresh your memory on some specific topics. But overall, let's say we expect that typical reader has some experience with machine learning, not very extensive, has some experience with software engineering, not very expensive again, and sometimes it's not even a practicing engineer or machine learning guy. It can be a role more relevant to management. For example, many people I know who are into management these days, they liked the idea of the book just to understand the high-level concepts of modern machine learning systems.
Yes, so it's explained a lot because one of my concern was about like some parts of the book are pretty complicated, but most of the book is pretty easy to read. So that was a question. So you keep this in mind that some readers will write like not through the book, but just partially.
Yeah, I mean, we try not to introduce unnecessary complexity while writing this book. So we provided, every time we were writing every chapter, we were always trying to be sure that we're not writing any kind of book for students on the third, I don't know, on the advanced machine learning course part 3. Though we provided a huge amount of links to the advanced materials. So if you're interested in a specific topic, you can follow the link, you can read. But again, it is designed, right? It's a meta book. You can review other book as a meta book of the book, book of the books, and the goal is to provide the overview, explain why is this something important, show an example, well, actually two examples. In every chapter we have two examples, and provide the just thought material. Then you can use further if you'd like to go deeper.
Okay, yes, and that was about my second question, that some parts of the book looks like you just show people the ideas about well-organized system, and some parts are more about inspiration, like how do you inspire like you inspiring people to how the system should look like. And it was like small contradiction, but it's pretty interesting to read. And did you keep in mind one of this approach, like showing the way, or to inspire people about?
I believe inspiration and showing the way are two sides of the same thing. Like, we definitely don't want to write a textbook. We wanted something that guides, a framework. And sometimes, or while following the framework, you need to do some pretty technical stuff and you need just a checklist. So for example, okay, you see your model is not training well and it means something is going wrong. There is a checklist of very common mistakes or failure modes, and you would like just to go through this checklist, and it is very technical. But once we are talking about earlier stage of system, when we are not sure what exactly should we build and should we build it at all, definitely it's more about softer concepts, about more abstract things other than direct technical recommendations. So definitely we could not keep the same style across the whole book, given the book should cover the whole evolution of a system.
And you've seen the book, though you haven't seen the whole book yet, because the whole book haven't been published yet, though it's written. And the book is split into 4 chapters. So I would say the more common chapter, or the chapter which might apply to almost any case, is chapter number 1. I mean, regardless, maybe chapter number 1, number 2, I don't remember exactly how they split, because regardless of what you do, what is the size of your company or anything else, you need to pick a metric, right? I mean, if you don't pick the metric, you don't know what you measured, it doesn't make sense to do anything. You need to pick a loss function for, regardless whatever it is, deep learning, it is a Gen AI, it is a tabular data, classical machine learning. Regardless, again, of all these things, you have to understand what kind of problem you're trying to solve, right? So you can review every chapter as a more advanced, more sophisticated step, and you might have no need in that all of them, but you need to know that they exist. And if so, that's kind of inspirational part, right? So if you know that they exist, the next time you will have something, you might apply that, you'll know, oh, okay, now I can do that. Because if you don't have a word, or in our case knowledge, for a specific block, you don't know what to do, where to go, what to look for, then situation comes.
Yeah, it's exactly about my next question. Like in second chapter, you introduce like basic idea about the general view of the system, like development paradigm, like to find the problem and around the finding the problem, like to generate a lot of ideas around this problem. After that, compress the ideas, and after that, from this compression, to build like the whole development plan. But actually, I worked with a lot of super small companies and like a super small startups. Do you think that this concept is universal for small companies, for like super big companies, but without special ML like division in these companies? So, do you think it's like super general concept?
I think, do you want me to dive in first, or do you want to dive in?
I think I have a good answer here because you are not the first person who asks something like this. Like it's a very common argument. Like, hey, I work for a small company. We don't need system design. We do not write design docs. Yada yada. And yes, one may think that system design is just for huge corporations. And if you work for Meta, you definitely need a design doc. But if you work for a startup of 5 persons, it's not necessary. But maybe it's not necessary to write a very formal design doc, but you still need to have some blueprint, some plan, what you're going to do, how you're going to approach it. So it may be very less formal, but still, even in small companies, small teams, I'm from a startup world as well, like you. All successful systems went through some kind of planning phase. It could be not as long. It could have maybe very primitive design docs. Maybe this design doc was like 2 pages of Google Doc, or I don't know, just a piece of paper. But still, there was some kind of very iterative design phase.
So let's review an extreme case, because if we review an extreme case or edge case, whatever you call it, and we'll find out we still need a design doc, this is an answer. Let's review an extreme case. We have one-person company. So a basic example, every time I personally go to grocery to buy groceries, it's much better if I have a list of things to buy, right? So even though it's just one person, you would say it's an extremely small team. And I guess each one of us has an experience of writing the code or thinking about something or creating something. So if we outline what do we want to create and the basic class, it makes our own lives much easier, because 3 months later you remember half of the things you've done and why you've done that and what is there. So I see you smiling, right? So you take a look at your code and think, okay, why did I do that? How does it work? Yeah, of course you can read your code, probably. It'll take some time. Now, if you just read what we're supposed to do, it is much better. So it's like in an extreme case with one-person team, either buying groceries or writing the code, writing the system, it's still much better to have some kind of documentation, right? Obviously, the more people involved, the more it's important to share the knowledge, to keep the knowledge, to be sure that, because people are coming and leaving, if you take big companies into account, and the knowledge might be lost. And of course, there are many agents. They might work in different time zones. They might not interact as densely as people sitting in the same room. So you have to you must be sure that this information is kept. So regardless, from one-person team to 5-person team to 500-person team, you would still like to have some kind of justification why this and that, what's been done, etc. Of course, it's a different level of details, and you might not need everything. A second point is that one of the best ML systems, IML system, which never were created and were replaced by the simple, I don't know, regular expression or set of ifs. So in a sense, if you sit with a piece of paper and you will outline what you're trying to achieve, it might become much easier to understand that you don't need anything sophisticated and complicated here. I guess, well, at least I had this experience, and I am sure that you guys also had this experience when you were coding something, you're doing something, and then you realize, oh, well, you can do that much easier. You can simplify that. You can replace it with the very basic stuff. So that's, in a sense, that's why the first couple of chapters of design doc is to understand if there is actually a need for machine learning system in the first place.
Yes, probably my comment was more about like, I have seen a lot of such companies when, for example, it was super common like 5 years ago when the computer vision was a new thing for a lot of companies. Like the companies that was built around like one randomly trained neural network. For example, like fruit detector for a robot, or like accounting for the cars, or like something like this. And there are still a lot of such companies. And they trained one model. It doesn't matter. It's like some students train this model, probably one of the founders trained this model, and they successfully built a company. And I saw a lot of such companies. And of course, when you start working with them, it's the first step, like to write the design document about every stuff that you wrote in your book. But like they already built a successful business, and sometimes pretty big business, with just randomly trained model from random data. And it's also sometimes happen, and I saw a lot of examples, but I don't know how. It's like it's not the only way, but probably it's, I don't know where the borders between like one types of companies and the other type. But of course, like in my opinion, of course, everyone should start from design document, but sometimes it's not working.
So
I am very sure there is some kind of selection bias in your narrative, because many companies that start with some very dirty solution, they do not survive at all, and only those who survived could hire you.
Of course, but like from the companies that hire our team, I think one-fourth of them, it was like these types of companies. So, but of course, like the probability of building your successful company is much higher if you will start from design document.
I'm not sure it is hard to build a successful company. It is hard to build a successful machine learning solution, which is just a proxy metric for a successful company. However, I think it's a false dichotomy. We like design doc doesn't have to be a monstrous, gargantuan, 100-page document. It might be 2, 3, 4-page doc, which helps you to remember why you've done some specific stuff and review that later. Also, there are different part of problem here, different problems here. So if your company continues to grow and you build something and you have no documentation how you build that, that's an issue which will backfire later. Well, probably that's why they hired you, right? And then, as far as I understand, you mentioned that they hired you and they had to spend this extra money on you, and you had, or you had to spend extra time, which is again extra money, trying to understand what's going on, trying to interview people who build that if they were still in the company. In some sense, it is always a balance between time and investment into preparation to actual delivery. But let's say that. Does it make sense to eat healthy food, to quit smoking, to drink a moderate amount of alcohol, no alcohol at all, etc.? Yeah, it does make sense. Does it guarantee that you'll live 100 years? No. Have we seen people who lived for 100 years with while drinking, smoking, and eating unhealthy food? Yes. Well, we know that on average, and the difference is significant, it is much more beneficial to do that stuff. So in a sense, you've seen the same. Yes. If you don't have a design doc, doesn't mean that you'll go bankrupt tomorrow. However, it's kind of tech debt, right? It's a technical debt, which the longer you're there and more sophisticated your system is, will backfire at you.
Yes. And speaking about like around the design doc, you in different chapters you show this a bit contradictionary. For example, like in chapter 3, you propose to inspire by a similar system. And in chapter 2, you say that a Procrustean bed of familiar machine learning algorithms. So where do you think it's like the line between like copying the solution of someone without like back thoughts and to development the solution, because like the first approach is like the examples I showed before, and sometimes it's work even like I want to copy this solution from this company. I don't want to think about this.
Well, talent copy, genius steal, right? So it's like a saying. There is no here's the problem. There is no universal answer to that. Does it make sense to look how other people try to solve the same solution? Of course it does, right? I mean, it doesn't make sense to reveal everything from the very beginning. Does it make sense to try to think, is there something different in your specific setup which might help you to escape the pitfall of other approaches? Because well, might be something very different to your approach or to your specific situation. Might be you don't need this, you don't have to reproduce exactly the same solution. So that's why you have to understand what kind of problem you're trying to solve. So I don't know, Arseny, I guess you have, because this pre-Christian bat was probably an analogy for that came from you.
Yes, that's right. And I think actually the book covers this question as well. I believe it strongly depends on what you expect from the system. So we introduced 3 buckets of the expected system performance, like some dirty prototype, human level performance, and best in class. And depending on your expectations, you may want to invest more or less in this kind of preliminary research, because when you do prototyping, you just take whatever works and you forget about it. And you just check how it works in more product perspective. Does it fit your business needs? Yada, yada. But when you do something that is expected to be best in class, when you would like to compete with the whole world and you would like to beat all of them, you definitely dedicate to all your resources to research, both preliminary and later.
Excellent. Okay, and let's go a little bit deeper in the design document. And I didn't find a few answers, but in my opinion, it should be like one of the basic question. And who is the owner of the design document?
Okay, so do you mind, Arseny, if I answer for a simple
Of
reason?
course.
Okay, so the last chapter, which well, you just revealed yourself that you haven't read the outline of the book, because this outline it states that there are 16 chapters, and the last chapter is ownership, right? So it's basically the name of the chapter kind of tells you that it will answer your question. So we have this ownership chapter, which basically it is a short chapter. It describes who is owning the document and why it's important. We also discussed the basic concept of the buzz factor, etc., 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 the importance of documentation. But your question was, guys, you haven't mentioned that. Our answer is, yeah, no, we had, you haven't yet seen that. Because it's kind of, you see, it's kind of behind the design doc, right? It's not exactly the design doc content, but it's more behind it. So that's why we've decided to put it afterwards.
Yes, but like with different owners, the design doc, I assume it should be built a bit different. Like if it's product owner, it's like one approach, and if it's like ML architect, it's like different approach, and so on. So don't you think that the owner can somehow change, like not even for formals, like specific terminology in the document, but like the concept and what will stay in the most important points and so on.
So here's what I think on that. there has to be a tag lead or whatever from the software engineering side or probably machine learning engineering side who is an owner of the document. However, it doesn't mean that all the chapters or sub-chapters within this doc, they have to be written by this person, right? You can assign different ownership of different chapters to a specific person. Like it makes sense probably to describe the problem chapter, to assign it to the product manager or product owner or even business stakeholder. It probably makes sense to assign other chapters. So let's say I'm a tech lead, but I have a researcher who can dive deep into specific set of loss functions and metrics which my model would benefit from. I probably would assign the chapter on metrics and loss function to this person, right? So it's a modular structure, but it's like a code repo. If you think about that, you might have a code repo which consists of different modules. And the reason one owner, usually, or the tech lead of the team working with the repo, I mean, of course, you can have a mono repo, but let's say sub part of mono repo of the code base. But still, it's kind of you have different people working on different parts. Fortunately, we can collaborate. So the same thing with design doc. It's kind of modular thing, which might have one main owner and a number of sub owners.
Okay, it's a good answer, but it will lead to my next question. How do you provide merge request to this document with such structure? Because if there are like a lot of changes, who will moderate these changes? Like, of course, like I am the owner of this part, but I want my part to be connected to like previous part, to all the different parts. And like if I merge my new commit in my ownership part, then it can affect somehow. And how do you think this communication should look like with changing some part?
So I think Arseny can add a word or two here, because basically we just wrote a book, and to some extent the process is very similar.
Exactly. I was thinking about this parallel as well, because, well, writing a book is somewhat similar to maintaining a huge code base, and obviously it is similar to writing a design doc. And for example, here in this book, we definitely have very shared ownership. Like every chapter is owned by a separate person. And we understand that we have weaknesses in our expertise. Like, for example, I have more experience in stuff related to deep learning. Valerii mostly worked with things related to time series, tabular data, and stuff. And this, it makes perfect sense for me to focus on stuff like, I don't know, inference optimization, and for Valerii to focus on stuff like reporting, because experience in big companies is required here. But still, even though I don't own some chapter written by Valerii, I may have one or two stories related to this chapter, or I might have some metaphors related to what he wrote. So it leads to some kind of iterative process when initial owner drafts the initial thing, and later I send comments to this document, and we may have some discussion, but the last word is on him, because, well, he's an expert here, and I'm just a random guy who has some limited knowledge or limited experience in this manner. But we luckily don't have to have a single owner across the whole book, because, well, it's just two of us, and that's a very limited scope. Usually for a big system, in the company, there is a single responsible person who is like definitely in charge for everything. And this person could break a tie. If you ask, what is the title of this person? I say, I have no idea, because it's not universal again. In some companies, it can be some project manager. In some companies, it's a product manager. In some companies, it's some staff software engineer. Whatever, it depends. There is no single answer. There is no silver bullet to say, hey, you have a title X, so you are responsible for this stuff.
Yeah, yes, because if there will be no one like responsible, then the overhead on the communication could be super big, in my opinion, because it's even when I saw a company like where like even 20 people work around one ML project, sometimes if like if there is no guy who lead the project and understand all the part about the current design, it's like, and everyone start to communicate with everyone like with different person, this overhead became super big, in my opinion. So the question how to manage this communication with when you start like you create first version of the system, you start having a feedback, you start working with your design document, you start changing all the part, and here is like communication overhead became super big. Don't you how you think it should be managed?
So my take on that is the following. Obviously, you have a small team of extremely skilled people. You can trust them that there will be a small amount of overhead, if any at all. They'll find their way, etc. Right? So apparently, there is no problem by definition. We have a small team, as a team of extremely skilled people, and thus we have all these heuristics like two pizza team, or in Scrum you have 6 to 12 people team as well, etc., 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 etc. Right? Pods, squads, whatever you call that. Now, if for some reason you have a huge team or a lot of stakeholders or whatever, and you don't trust them and they're not skilled, there is a lot of overhead and squabbling. Well, I mean, nothing prevents you from having a design doc being hosted on GitHub and having the same code review or design doc review, right? Literally nothing prevents you. You have the version control. It's still text, so it doesn't take that much space anyway. It's not like you have to store gigabytes of data. So again, it's up to you. It's more like given your specific environment, your constraints, your team, and amount of time and investment you have, what do you want to introduce, right? So in my experience, Google Doc works pretty well. You have a suggestion, you have comments, you can see different versions and changes, though it's obviously not as good and useful as something on GitHub where you can see the blame, you can revert, you can introduce approved by 1, 2, 3 people, etc. So depends.
Yes. Usually we worked with like mirror board, and it works super good for this case. Like it's like a Google Doc, but with 2 dimensions. Okay, and let me switch on the bit different topics. And you have a good chapter on loss function and on and the different on the metrics. Probably my question will be like also around the chapters that you not published yet. So and it's about so in my opinion the data set goes first before all of this loss function and so on. So and because all these loss functions they but of course I speaking from like computer vision, more from computer vision perspective, and the data usually it's harder to obtain and so on. And from this perspective it's usually everyone starting from collecting the data and like from corner cases requirements and so on. So and it's super good chapter, but like when I look into this chapter, I was thinking that it's too early for this question. And my question will be like, don't you think that book it's more like about the classic ML than about the computer vision?
So I will speak on that because I mostly contributed to that, and Arseny is mostly contributed to deep learning part. So we kind of can tackle it from both sides. So one chapter has to be before another by the problem that we can't read simultaneously different chapters, right? It doesn't matter that you have to do one thing before another. However, I still think that even before gathering the data set, you kind of trying, even on the basic level, to understand what kind of task you're trying to solve. I mean, is it classification task? Is it the detection? Is it segmentation? Is it generation? It is face recognition, right? Whatever. But you kind of understand what kind of task you're trying to solve. It's not like, oh, let me gather some kind of data set and then I will understand what I can do with that. No, usually you kind of have a problem at hand. Then as soon as you have problem at hand, you already have a kind of at least a basic understanding how would you, what kind of problem is that? How would you measure, right? Even if you don't think about that. So it's a matter of discussion what comes first. In my opinion, metric still comes first, even on unconsciousness level. Well, let's say probably the metric and the quality you want to achieve would affect how much of the data you need, right?
Sometimes I can tell you how usually I build such system at the beginning. So usually I keep in mind like from 2 to 5 different algorithms that can be used there. And keeping them in mind, I build in like the labeling guide for the labeling team. And usually in this labeling guide, I tell them, for example, like you need to put these tags on these images, you need like to put these detections, you need like to put this, and usually it will be enough for any type of the system that I will build after. And after the labeling, I will look at the data, and for example, I will either ask the labeling team to label same data 2 times, like with different persons, and I will compare how accurate will be my different hypotheses about this data. And only after that, I will like choose the final metrics, final loss function, and how I will approach to this data. And sometimes I will not even choose on this point. I will look like that the data is bad, and I will ask them to collect more like corner cases or something like this.
So you basically just confirmed what I said is right, because you said before I gather the data set, I have a set of metrics I will test this data sets upon.
Somehow yes, but I will not even write this last function before the data.
Yeah, I mean, you probably don't have them because if it's one person team and you know what you would test for, you kind of already have this mental picture, which you probably didn't have from the very first time you've done that. So that's why I mentioned these unconscious metrics already presented you. But you basically said, okay, guys, even before I collect the data set, I will then run them through the number of metrics and loss to pick the best. Right. So, but okay, so probably if you're working on segmentation, let's say, you would use some kind of whatever intersection of a union, Jaccard, or you name it. You won't use log loss or I don't know, root mean squared error, right? Which doesn't make sense in that case. So you already have like a short list of metrics. Yeah, not
yes,
you obviously from gather the data set and then create this set, but
usually it's like this, but I can remember one time there was a bit different approach, because after we test all these initial ideas with the label data, we just totally change all the metrics and all the approaches. But yes, usually like it's discussable. But my question was like about don't you think like it more from perspective of classic ML, and I have the second thoughts from different chapter. It's like from the validation chapter about like I never saw like k-fold nested validation except like Kaggle, for example. So for the computer vision, it's not like super common approaches, and like the validation usually is super simple. So my question was more about, yes, it's discussable what comes first, like data set or the metrics, but don't you think that it looks like it was built more like from a classic ML perspective, not from computer vision?
Well, again, your example in validation means that you basically can always make it easy, right? In a sense, what you do, you use a k-fold of k2 for validating your system. You have a train and test, or k-fold of 3. You have train, test, and validation. And I don't know, you're probably using some kind of augmentation if you train computer vision algorithms, so which makes it a bit more complicated than you just stated. But look, Arseny, I'm stopping here because I saw rage on your face. Yeah, maybe you haven't noticed that, but I know Arseny for many years, so I'm stopping here and I'm giving you the word.
Okay. That's a good question, and we again faced this question before, because people ask, "Well, can I read your book? Should I read your book if I'm doing just tabular data, or vice versa? Should I read it if I'm doing some super cool computer vision, state-of-the-art generative AI?" And I prefer to answer yes, because obviously some techniques are more focused on classical ML. Like definitely in computer vision, you don't spend that much time on validation if you have like a huge data set and have a model that trains over 2 months with 1,000 GPUs. Obviously, no way for complicated validation schemas. But at the same time, it's not just black and white. You can imagine a situation when you do some computer vision, but your data set is small, your models are small, and you have capability to do complicated validation because your data set is small. You cannot have a bigger one, and you need to squeeze as much as possible from this small. And once you would like to squeeze the maximum performance from such environment, you need a strong validation you can trust. At the same time, there are some techniques that are usually used in classical machine learning that can be transitioned to deep learning as well. Like one example is somewhere in the feature engineering and feature selection chapter. And that was one example from my own experience. When the company I worked for used language models, and the approach was we gather some stuff here and there into a single prompt, and this prompt as a string is passed to a BERT-like model. Obviously, very deep learning, huge data sets, a lot of GPUs, but effectively, all these components that are stuck together, they are features of this model. And to reduce amount of data, to reduce latency of the system, I applied very classic feature selection things. So I think we tried to build some kind of bridge between classical ML and deep learning. And I think that people who say, I'm only doing classical or I'm only doing deep learning stuff are not very smart. You need to pick your own tool for the problem. And sometimes you need one, sometimes you need another, sometimes you need a combination. We tried to maybe give some intuition how you should pick tools from here and from there. And obviously, some chapters are more relevant to some problems and vice versa. Like definitely, The inference chapter is very focused on deep learning because, well, if you do logistic regression, there is not much you can optimize in terms of inference. And same for feature engineering. You cannot often optimize features for deep learning, but sometimes it happens, as I said.
Yes, it's great. Great. I also think that it's like the one big process from the basic models to some deep learning models, and I also think that the person who developing the solution should understand all the possibilities, of course. And it's more was question about like the focus. Okay, doesn't matter. My next question will be about MVP part. It's a really great part, and I completely agree that the first solution should be as simple as it possible, and of course, like you should start from this, and if the first solution could be run on the prod, it's great. But my question will be about like the traction from this first solution to the final model. Usually it's continuous like it's continuous pipeline, like from the first baseline. After that there is some modification, some changes, and actually, like you wrote in the book about, you will have version 1, version 2, version 3, but actually it's not like versions, it's like continuous integration of the baseline to the project. And when do you think the baseline when you can call the baseline the product? What you should achieve to cross this gap? And how it's like should it be like metrics when you can build the metrics? Should it be like more business requirements? After it hits the business requirements, it's already the product. And how do you think we should work with this?
So let's split two things. Let's separate MVP and a baseline solution. So the baseline solution is basically to receive the most in the least amount of time, knowing that there is always something you can do and improve. In that case, it's like a red queen's race. You have to run as quickly as you could just to remain in the same place, and to go somewhere else, you have to run twice as fast. So in a sense, whatever you do, whatever you improve, it just becomes a new baseline. So basically, it's just a set of baselines. So you start from a simple thing. It doesn't make sense to invest a lot. You see the first results, and then you try to understand, okay, how much else do I need to invest to receive more? Does it make sense? So, and of course, we stated in the book that you need to start from a very simple solution. You build simple solution. You kind of read that's again. You to some extent you just said the same 7 minutes ago when you mentioned that you received you gathered number of data sets, you run them through a set of metrics. When you pick the best one, then you reiterate, etc., etc., etc. So it's always back and forth, back and forth. It's never ending process. Your new improvement, new and improved model is a new baseline. But it's not an MVP, right? It's a baseline in terms of machine learning system. So in a sense, it works from day one, as soon as you have everything in place. It works with baseline, then you try to improve this baseline. That's why there are always people. So take, for example, Google search engine. If you join Google search now, you have a very strong baseline, a very strong baseline. But there are still hundreds of people, if not thousands, working hardly to push it further, to make it 1.1%, 0.1% better, 0.2% better. That's why we had this transformer architecture, which came from Google and is widespread, and it created all this GPT, all this cloud, etc. Because those smart people needed to push their baseline, but their baseline was so advanced that then they were able to push it. It was a breakthrough.
And to answer the original question, I would like to say that you actually had an answer in your question itself. So you asked, should we wait for a metric to be achieved or some business requirements or whatever? Well, requirements are complex and they can cover different aspects of the system. Like metrics is one thing, some additional business constraints is another thing. Finally, we have some non-function technical requirements like latency or hardware required to host stuff. So once we reach the lower boundary of everything, this baseline is ready to go.
Okay, so in terms of terminology, even your final solution will be a baseline if you will develop the next one. Okay.
At some point.
Yes. So it's more about like terminology in this case that someone probably will not happy that the solution will be baseline. Okay. And my next question is super general. How difficult it's to write new chapters with predictable frequency, and when the next chapter will came out, and what is your next traction to the final book?
This complicated. Writing chapters is complicated, and polishing chapters is even more complicated. Like again, you have a baseline, but later you understand that you are not extremely happy with the baseline, and we have to adapt. We have to reflect some news. For example, when we just started the book, there was no GPT, and nobody cared about transformers. Nobody cared about large language models at all. But at some point, everyone is there. When we started the book, serverless inference was a rare thing. Now there are multiple startups who try to do it, and they receive huge investments. So there are many aspects that need to be updated. And that's why we still polish our later chapters. We polish less our early chapters. They're mostly good, but our later chapters, all of them are written, but they need some work to be finished. So I'd say we have maybe 3 final chapters that still need additional examples, need to be polished, need some images to be introduced, and so on and so forth. And as for the release cycle, actually, it's not something that is really in our control, because that's the publisher who wants to set the cadence of this release. And we mostly follow their cycle because, well, definitely they're experts there. We are not.
Yeah, I would say we have provided. Let's say that the book is almost completed, at least the draft phase, because after every chapter is completed or written, it has to be read by both me and Arseny again, regardless of who's written this. Usually, it's like if it's mostly my contribution, then it's time for Arseny to contribute and to read this, and then we discuss the suggestions, and then we kind of leave it for a week or two, and then we read it again. And then we also have a designer who helps us to improve our initial images. As you can imagine, initial images are far from ideal. Then we have our own internal technical editor who again reads that. He then circles it back to us. We edit it, circles back and forth. And that's the time when we send it to the publisher. There is a publisher reading them, a technical reviewer reading the chapter, and then they send their comments back. So far, I would say mostly we received a good like not even the good feedback, like only the praise, most of the praise, because at the time they receive it, it's already gone through like a multi-layered review process. But it takes time, and so whatever you call a finished product, right? A draft fully reviewed by our internal team, a draft reviewed by external team, but the book itself is written like 97%, 95%. That you can see that only half of the book is published, right? So it tells you something.
Yes, yes. And when the next chapter will, because for now it's like 8 chapters, I assume. And when the 9 will be?
I have no idea, Arseny, because as far as I
Okay.
understand, we are already working with publisher in chapter 12, right? So that means the chapter 9, 10, and 11 already were accepted by them. So you see, they like already like 11 chapters were accepted by them, but they kind of probably have a cadence. I think it's kind of linked to their marketing campaign or something like that. So, so let's say that we published the book in April, right? And originally we have what 5 chapters there, right?
5 chapters, I think.
And since then they publisher added 3 more. So like April, let's take it outside because it was 26th of
Yes.
April. Let's say May, June, July, and August. So it's almost 1 per month, right? So we can expect the new one coming pretty soon.
Excellent. I will be happy to read it. Thank you for the interview. It was great. Yes.
Pleasure's
Good
mine.
luck.
Thank you. Thank you very much.
Thanks,
Take
Tom.
care. Bye.